Hello grade 8 students, I hope that you are doing well. In this video we will solve an exercise to apply the previous explained notes and to explain some new notes. So please, I want you to open your copybooks and copy everything. Let's read the exercise. Given that L2 and L3 are identical lamps, so these two lamps are identical. A voltmeter was used to measure the voltage across the dry cell and L1. The voltmeter showed that the voltage across the dry cell is 12 volts. The voltage across the dry cell equals to 12 volts. So UPN equals to 12 volts. And the voltage across L1 is 6 volts. The voltage across the first lamp is 6 volts. UAB equals to 6 volts. 1. I have to draw the voltmeter on the diagram that is used to measure the voltage across L1. 2. If the switch K is opened, I have to find UL1, UL2 and UK. UL1, by UL1 I mean UAB, by UL2 I mean UBC, and by UK I mean UPA. Part 3, switch K is now closed as seen in the figure. Deduce the voltage across the switch. Calculate the voltages UL2 and UL3. 4. An ammeter is used to measure the current that is flowing in the circuit and it showed 2 ampere. I have to find the current that is flowing through L1, L2 and L3. So I have to draw the voltmeter on the diagram that is used to measure the voltage across L1. As we said before, that the voltmeter must be connected in parallel. So here I have to connect the voltmeter in parallel. So here you have to draw the voltmeter. That's the voltmeter. And as we said before, that the COM terminal of the voltmeter must be connected to the negative terminal of the dry cell, on the negative terminal of the dry cell, to get a positive result. So here the voltmeter will read 6 volts. How did we know that the voltmeter will read 6 volts? Since in the given they said that the voltage across the first lamp is 6 volts. That's part 1. Part 2, if the switch K is opened, find UL1, UL2 and UK. So the switch is open. I have to find the voltage across the first lamp, the second lamp, and the voltage across the switch. UL1, which means UAB. So lamp 1 is between 2 points A and B. So I can write UAB or UL1. It's the same. UAB, since the switch is open, UAB equals to UBC equals to UCD equals to 0 volts. Why? Since the switch is open, so the current is not flowing in the circuit. But now I have to find the voltage across the switch, which is UPA. The switch is between these 2 points, P and A. So we can say UK, which means the voltage across the switch, or UPA, which also means the voltage across the switch. So here UPA equals to UPN equals to 12 volts. Here I have a rule. You have to memorize it, guys. The voltage across an open switch is equal to the voltage across the battery. Okay, so when the switch is open, the voltage across it equals to the voltage across the battery. Part 3. Switch K is now closed as seen in the figure. I have to deduce the voltage across the switch and I have to calculate the voltages UL2 and UL3. So part A, let's start with part A. Deduce the voltage across the switch. If you notice from the figure, the switch is closed, so it acts as a connecting wire. UPA equals to 0 volts. Why? Since the switch is closed, it acts as a connecting wire. So now we have two rules. When the switch is closed, it acts as a connecting wire, so the voltage across it equals to 0. But when the switch is open, the voltage across it equals to the voltage across the battery. B, I have to calculate the voltages UL2 and UL3. So I have to calculate the voltages UBC and UCD, or UL2 and UL3. In the given, they said that UL2 and UL3 are identical, which means that they need the same voltage to function normally. So if this lamp needs 10 voltages to function normally, this lamp needs 10 voltages to function normally. 3 voltages, 3 voltages. So they are identical. To find the voltage across UL2 and UL3, I have to apply the law of addition of voltages. UPN equals to UPA, we just follow consecutive points, plus UAB, plus UBC, plus UCD, plus UDN. UPA is crossed out. Why? Since we have a closed switch between these 2 points, the closed switch acts as a connecting wire, so we cross it out. UDN is also crossed out. Why? Since it is a connecting wire, so it's equal to 0. Instead of UPN, we can write 12 volts. It's given. Instead of UAB, we can write 6 volts. And now we have UBC plus UCD. The remaining voltage for these 2 lamps equals to 12 minus 6 equals to 6 volts. So these 6 volts must be distributed for both lamps. Since UBC and UCD are identical, so the second lamp and the third lamp are identical. How do we find the voltage across each one? So UBC equals to UCD equals to 6 volts divided by 2. So each lamp needs 3 volts. Why did we divide them by 2? Since we have 2 identical lamps. If they told us that I have to calculate the voltage across 3 lamps and they are all identical, I divide it by 3. Okay, so since 6 volts are remained for both lamps, I divide 6 volts divided by 2 since they are identical. Part 4, an ammeter is used to measure the current that is flowing in the circuit, and it showed 2 ampere. I have to find the current that is flowing through L1, L2 and L3. According to the law of uniqueness of current, in a series connection, the current is constant. So IL1 equals to IL2 equals to IL3 equals to the main current equals to 2 ampere. Thank you guys. Please copy this exercise on your copybooks, and if you have any question, please don't hesitate to ask me.